In an unexpected development, NASA's James Webb Space Telescope has made a discovery that has astronomers around the world surprised. A few weeks earlier, the James Webb Telescope identified the earliest recorded galaxy in the universe. However, it has now located something even more tremendous. It's a colossal black hole, retreating from its galaxy at an astonishing speed of 4 million miles per hour. This recent discovery carries profound implications and has ignited considerable speculation among researchers and space enthusiasts regarding its significance for our understanding of the cosmos. The James Webb Space Telescope was launched on a mission to discover the first stars and galaxies in existence, and has captured stunning images of the death of stars and galaxies from just a few 100 million years after the Big Bang. We invite you to join us in examining the latest insights from this telescope. Remember to like and subscribe. For more content like this, the latest discovery is challenging the scientific community's prevailing understanding of black holes. Black holes are normally viewed as enormous entities that pull everything, including light, inward. However, the recently discovered black hole appears to demonstrate the opposite effect. Instead of absorbing light, it is producing new, young stars along an extensive path. This new trail of infant stars has been detected trailing the black hole, extending an impressive 200,000 light-years away. Scientists are perplexed by the unusual behavior of this black hole compared to others. Nevertheless, a team led by geoastronomy professor Bayenda recently published their findings in the Astrophysical Journal Letters. NASA's Hubble Space Telescope also confirmed these observations, suggesting that the black hole triggers new star formation when it interacts with gas and cools it. We are witnessing the wake behind the black hole. But that's not all. NASA has released an exciting statement about the galactic collision ARP-220, captured by the James Webb Space Telescope. This remarkable galactic merger can be seen shining among other galaxies in the night sky. When spiral galaxies collide, the phenomenon known as ARP-220 shines most intensely in the infrared spectrum, making it ideal for observation using the James Webb Space Telescope. It is classified as an ultraluminous infrared galaxy, boasting a brightness equivalent to 1 trillion suns compared to our own galaxy, the Milky Way, which has a much lower brightness of about 10 billion suns. ARP-220 is located in the constellation Serpens, about 250 million light-years away. It is regarded as the brightest of the 3 nearest galactic mergers, too. Earth and is catalogued as object number 220 in the Atlas of Peculiar Galaxies, around 700 million years ago. Spiral galaxies collided and sparked a massive burst of star formation. This created a dense region about 5,000 light-years across, containing roughly 200 giant star clusters. Remarkably, this compact region holds as much gas as the entire Milky Way. Earlier studies with radio telescopes revealed nearly 100 supernova remnants within less than 500 light-years across. Later, the Hubble Space Telescope confirmed that the parent galaxies are separated by 1,200 light-years, and that each core contains a rotating ring of star formation emitting incredible infrared radiation. The most recent images from the James Webb Space Telescope reveal an impressive galactic merger of the two galaxies. This image also displays faint tidal tails stretching from the edges of the merger, indicating the gravitational forces between the two galaxies. Additionally, the reddish ochre and orange streams and filaments represent dispersed organic materials. In ARP-220, another astonishing discovery puzzled scientists when researchers identified primordial galaxies at the edge of the universe. Initially, there was skepticism about their authenticity. Some suspected they might be nearby galaxies in disguise. So, they shared the data with scientists worldwide, hoping for verification. Amazingly, the James Webb Space Telescope confirmed that these ancient galaxies are real. Thanks to this modern telescope, we are now able to observe the oldest galaxies ever recorded. Astronomers estimate that light from these galaxies has traveled more than 13.5 billion years to reach Earth, providing a glimpse into the distant past of the universe. These galaxies formed when the universe was still young, shedding light on how quickly the first generations of galaxies emerged. The spectral data showed that these galaxies are at the edge of our sight, some even farther than what Hubble could detect. This discovery is vital because it confirms one of the most important goals of the James Webb Space Telescope: to observe the early universe through light that has traveled for over 13.5 billion years. The ability to measure extreme redshifts sets James Webb apart, allowing astronomers to peer into the infrared range and examine the first galaxies in the cosmos. The excitement is palpable as this finding marks a significant milestone in the study of the universe and in understanding its evolution. The discovery has profoundly impacted our comprehension of the universe and has inspired NASA to develop even more powerful telescopes than the James Webb Space Telescope to confirm whether our current understanding of the Big Bang is correct. Data acquired from Webb's F spectrometer and near-infrared camera show that 4 of the 6 primordial galaxies display extreme redshifts, implying that Webb is viewing them as they existed 300 to 500 million years after the Big Bang without heavy elements such as carbon. This is unexpected, since the universe is estimated to be 13.8 billion years old, and the existence of these galaxies suggests that we need to revise our knowledge of the early universe. This has raised concern in the scientific community, as these new discoveries challenge the current cosmological inflation model and the Big Bang theory, which contains some inconsistencies, such as conflicting with the laws of thermodynamics and lacking a clear explanation of what brought on by the Big Bang. Moreover, the James Webb Space Telescope is uncovering galaxies almost as ancient as the Big Bang itself, challenging everything we thought we understood about the universe's origin. According to theoretical physicist Miyoku, the discovery of ancient galaxies through the James Webb Space Telescope has challenged all prior knowledge about the universe's beginning. Formerly, these galaxies were believed to be less evolved than the Milky Way. However, the new findings suggest that important records may be missing. The fact that the telescope has recognized 6 galaxies that existed half a billion years after the Big Bang and are up to 10 times larger than the Milky Way raises the question of whether our present-day theories about the universe's formation are correct. Kaku explained that it takes billions of years to shape a galaxy like the Milky Way, so it is unusual to locate such large, young primordial galaxies. This discovery may compel us to revise and rewrite textbooks about the universe's origin. Findings from the James Webb Space Telescope mission are reshaping what we thought we knew about the Big Bang, putting scientists at a crossroads. Regardless of this, NASA recently tweeted about a galaxy cluster that exists just 650 million years after the Big Bang, adding yet another intriguing piece to the puzzle. Astronomers analyzed the data and concluded that this nascent cluster is expected to grow in size and evolve into something similar to the massive Coma 1656 cluster. The region where all this is happening is unique and significant, as it lies in an area of increasing galactic evolution. Thanks to the James Webb Space Telescope, researchers can now measure the velocities of those 7 galaxies, giving them the confidence to verify that they are gravitationally bound in a protocluster. To demonstrate, NASA scientists compared these distant galaxies to small droplets of water in separate rivers, which will ultimately merge to form a huge, powerful river. Clearly, what we previously believed about the Big Bang is not aligning as expected. However, more information from the Webb telescope may provide evidence to either confirm or refute the concept. Who knows? Perhaps the Big Bang did arise, but what triggered it remains another matter. Anyway, we must await further discoveries. But the answer might be closer than we imagine. What are your thoughts on these discoveries? Share them in the comments below, and I'll see you in the next video. Thank you very much for watching, as we continue gathering data from the James Webb Space Telescope, JWST. One truth becomes clear. We're entering a new era of cosmic exploration, one that requires us to rethink our most fundamental assumptions. Not only is JWST helping to validate or question existing theories, but it's also raising entirely new questions that scientists had not yet considered. For example, the presence of complex structures in these early galaxies, including mature star clusters, potential supermassive black holes, and significant stellar mass residues. Concerns about how rapidly these systems could have formed after the Big Bang. Are our cosmic evolution models missing a critical element? Could there be unknown physical processes enabling galaxies to form and evolve faster than currently believed? In response to these revelations, cosmologists are revisiting theories such as early dark energy, special particle interactions, and modifications to general relativity. Some researchers are even exploring alternative cosmologies, including the cyclical universe model or bounce theories, which propose that the universe might have undergone previous cycles of contraction and expansion before the modern Big Bang. Meanwhile, back on Earth, NASA and its international partners are already discussing the development of the next generation of space telescopes. Missions such as the Nancy Grace Roman Space Telescope, LOVOIR, and HEBOX are being designed to complement JWST by focusing on areas like dark energy, exoplanet imaging, and the search for biosignatures on distant worlds. Speaking of exoplanets, the James Webb Space Telescope is also making substantial progress in this field. Its powerful spectrometers can now analyze the atmospheres of planets orbiting distant stars. Already, JWST has detected water vapor, methane, CLID, and even potential traces of carbon dioxide in the atmospheres of exoplanets many light years away. These discoveries bring us closer to answering one of humanity's oldest questions. Are we alone in the universe? Every image, every spectral line, every faint infrared glow brings us closer to understanding the vast cosmic web of which we are a part. The early results from JWST are not just fascinating, they are revolutionary. They show that science is not fixed and that progress often comes not from answers, but from the courage to question as we await further findings. One thing is certain, the universe is far more complex, dynamic, and mysterious than we ever imagined. The James Webb Space Telescope is not merely observing the cosmos. It is rewriting the story of our cosmic origins. Stay tuned for more updates. And don't forget to subscribe for future deep dives into the most groundbreaking discoveries from space and beyond.